Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. This time with a massive head cold, so let's hope my nose doesn't leak out all over my desk while I'm talking. In the previous video, I gave you the definition of a new derived rule, substitution of equivalences. The next step is to show that this is a legitimate rule. Legitimate in the sense that it's a proper derived rule. Anything that we can prove with it, we could have proven without it. So all it is doing is giving us shortcuts, and that the rule is sound, which follows from the previous one, but it's also worth kind of doing explicitly. So namely that if we start with something that is valid and we apply substitution of equivalences, the result will also be valid. We're not going to do that in this video. That's going to come next, but en route to both of those goals, I'm going to prove to you a very simple normal form lemma, namely that every modal formula is equivalent to a formula that involves only negation, disjunction, and necessity. So we can get rid of all of our conjunctions, conditionals, and diamonds. And the reason why this is useful is it means then when we come to the case where we are considering the soundness of this rule, we only have to consider 4 cases. The basis case, i.e. when we have an atom, the case of negation, the case of disjunction, and the case of necessity, because all of the other cases will just reduce to those 4. So this is why normal forms are useful. Now, I'm going to share my screen and I'm going to clear everything here because that wasn't supposed to be there. The lemma that we are going to prove, as I said, is every modal well-formed formula is equivalent to one involving only negation, disjunction, and necessity. Now, you might be saying here, well, what about atoms? They don't have any connective. Well, every atom is equivalent to not P. So it holds for atoms as well. So this can always be converted into this, which does involve negation and only negation. Anyway, this means that we only need to care about the cases of conjunction, disjunction, and diamond. Because if our formula already doesn't have any of these, we're already good. It's already going to be equivalent to something that only contains negation, disjunction, or necessity. Now, both of these cases, the cases of conjunction and conditional, go back to something that we saw in video number 56. I had to go and look it up. So if you couldn't remember which video this was in, you're forgiven. I couldn't either. And this is not did not finish, but disjunctive normal form. And this is where we talk about how you can take propositional formulas involving these connectives and turn them into equivalent ones that don't involve these connectives through successive uses of De Morgan's laws. So if you have phi and psi, you can always convert this to not phi or not psi. So look, only involving disjunction and negation, doesn't involve any conditional. And also for the conditional case, the equivalence between P or Q and not P implies Q, which also follows the equivalence of not P or Q and P implies Q. So what you can do at the purely propositional level is just reduce it to just disjunctive normal form and you're good. Now we have the diamond that we need to consider, and this just recognize one of our equivalences from some ways back at this point, which is that not necessarily not phi is equivalent to possibly phi. So if it's not the case that everywhere you look, phi is false, well, then it means that there is at least one case where you can look where phi is true. So there you go. As I said, the reason why this normal form lemma is useful is because it means that we only have to consider the atomic case, the case of negation, disjunction, and necessity when we are proving the soundness of the substitution of equivalences rule. This is because anytime that we have one of these, we can get rid of the diamond just by replacing it with the not box not. And we can use all of the equivalences necessary to put something into disjunctive normal form. We don't have to go to disjunctive normal form. We can just use the equivalences to get rid of all of these things. And then we're left with a simplified set of cases that we need to consider. And these cases we will consider in our next video. Until then, take care. Try not to let your nose leak out your brain, and I'll see you soon. Cheers.